everyone. Welcome to, I'm not sure what session this is, probably at least the 6th or 7th session. We're going through telecom overview of the industry, of the architecture, the identities. We've covered identities. We've looked at architecture. We're doing a little bit of that now, along with the mobile generations. Let me open up a chat window here, and just so if you have anything, I'll glance over. It's on my other screen here. I'm to the right of me. So if you see me glancing over here, it's to the right. The slides are to the screen in front of me. So we ended up last time somewhere around, let me see, somewhere around here. We're talking about the different generations, the different air interface, and we're going through the different generations, and we don't want to, two things. I don't want to overemphasize what was in the past, because again, a lot of these systems, some of them are not there. There is still second generation out there, but to me, it's important to understand that certain things, regardless of the generation, certain things have to happen. You still have to do an update location wherever you're at. You still have to have the ability to hand off from one system to another system, or from one cell to another cell. You still have to authenticate. You still have to get information from your subscription information into your serving system. So all these things have to be done, just that they're done differently. That's number one. Number two, from second generation on, there's still a lot of second generation systems. There's many in Central America and South America. There's certainly in the Middle East. In Asia, there's a lot of second generation systems out there. They're slowly, somewhat going away, but being replaced by other systems. But there's still a lot of 2G, 3G out there. And I think if you understand what's gone on and how it progressed through the different eras, we can also understand how the different signaling methods have changed from SS7 to diameter, and we'll talk more about those. So we ended up here talking about second generation systems, and one of the things was, remember, there was a lot of second generation systems, but there's one that really dominated, and that was the one that was written by the European Telecom Standards Institute. That was ETSI, and that was called GSM, Global System for Mobile Communication. And when we compare kind of some other systems with what happened in GSM, why did GSM dominate the world? Why that one technology? Was it a superior technology, or was it something else? Well, as it turned out, it was the fact that everything was standardized. Everything from the air interface, the modulation on the air, the communication between the radio and back to the mobile switch, the common communication from the mobile switch to all of these other registers and devices, all those were standardized. So that dominated. Where you look at other systems, primarily if you look at like the United States, there was all different kinds of air interfaces. On the left-hand side here, there were some that were still first generation, which was frequency division multiple access. There were some that were narrowband frequency division multiple access. There was two different types of time division multiple access. There was code division multiple access. You had all kinds of different air interfaces. You had different signals between the different cell towers and the mobile switch. The signaling protocol was common, but everything else was different. Whereas over on the right-hand side, if you look at GSM, all the SIM cards were the same. They plugged into these phones. You had frequency division and time division multiple access. The frequencies were assigned. It was an 8-time slot system. The communication between the cell towers and the base station controller back to the switch, that was defined by GSM. The communication was defined. So it was one standard, and that standard, if you signed a roaming agreement, it would work from one system to another. So roaming really took off back in the 1990s, especially among companies or countries that deployed GSM. So we take a look at what is contained in the GSM system. Well, again, every system, regardless of the generation, is made up of three major parts. One is the user equipment. In the case of GSM, back in the 90s, that was just a mobile phone. Today, it's other things. Today, you have IoT devices, you have sensors, you have a lot of things that use telecommunications networks today. Back then, it was just a phone. And you had some kind of radio. It's called a RAN, radio access network. Now, that radio access network, that was that common modulation. That was a time division, multiple access, and frequency division, multiple access here on the air interface. The communication back to the base station controller. The base station controller would control some number of cell towers. These cell towers were called base transceivers, or base transceiver stations. That was just the name of the cell tower. You had a common communication path back to the mobile switch. And the mobile switch would connect for voice signaling, for voice communication. It would communicate with the wireline network. That's called the public switched telephone network. It would other wireline networks, and it would connect up to other mobile networks, mobile network operators. But it would also communicate with its own internal devices. These internal devices are what makes mobile work. You need certain registers, you need databases to authenticate, you need databases to keep track of where your subscribers are at. These are registers or databases. This common signaling, this common way of communicating, the way the data is formatted is SS7, Signaling System 7. So the mobile switch would communicate with a visitor register. In other words, that's the database that keeps track of all the current users in that particular switch. There's a home location register, an HLR. That's your central database that has it houses all of your subscription information. It knows if you have any restrictions, it knows what you subscribe to. It also knows the switch where you're currently located. If you get on a plane and fly to another network and go to another country and turn your mobile phone on, messages will come from that network to your home system. So your home system knows where you're at. It doesn't know down to the cell where you're at, but it does know to the switch. Authentication Center. It's a database that is used, just what it says, to authenticate you. Prove to me that you are really who you say you are. That mobile phone, the network will demand that the mobile proves itself. So it's really you that's on that phone. Now, it doesn't always work. We'll talk more about that later. Equipment identity register, we'll talk about that. Message center. When you tap out a short message to someone, that's going to go to your message center. Your message center then has to go find the recipient. Once it finds the recipient, it tells the message center, here's where to send the message to. And the message gets sent there. So this is a common signaling protocol. So all these devices talk to each other. So this is a list now of what all these different piece parts are in a mobile network, starting with the mobile station. The mobile station is made up of the telephone, which is called the mobile equipment, and your subscriber identity module. That's you. That's your identity. Your international mobile subscriber identity is contained on that card. The cell towers are called base transceiver stations. That's your cell tower. That's your radio interface into the network. And the cell towers, some number of these will communicate to one controller, and then you have multiple controllers. So you have multiple base transceiver station cells communicating with multiple base station controllers, and they all communicate back to the mobile switch.
Hi,
So
Steve.
the base station controller, yeah, please, questions.
Yes, I was wondering for the SS7, is there a reason for the 7 there? The
No, that's
SS.
a good question. Why is it called Signaling System 7? There used to be a SSI6, Signaling System Interconnect 6. I don't know how that got that name. That was back in the 1970s. And that's a good question. Why did they name it SS7, Signaling System 7? That I think is, we're going to list that under mysteries because I really don't know. It's just one of those things that no real reason. Good
Okay.
question, though.
I'll do a
Good
research
question.
on it. So,
Yeah, no. The base station controller manages the radio. So this is responsible for managing all of these cell towers out there. It communicates back to the mobile switch. And the mobile switch has internal to it a visitor location register, a VLR. It's listed down here, visitor location register. That's your temporary storage of subscriber information. Whatever switch you, on your mobile phones now, whatever switch you are currently in, you will have a copy of all of your profile information inside the visitor location register. When you power this mobile phone on and the signal goes over the air, it goes back through the base station controller to the mobile switch. The first thing the mobile switch does is it asks its own internal VLR, do you know who this is? And if the VLR knows about you, it says, yeah, I know who you are, and it just makes note of your signal strength and the time of day, and that's it. If this is your first time though, if it doesn't know anything about you, it's going to send an SS7 message from here, to the home system, to the home location register. It's a database. That's your permanent storage of your subscriber information. And a copy of your profile goes here. If you're in your home system, that just stays within the network. If you're roaming though, if you get on an airplane and fly into Dublin, Ireland, and power your mobile phone on, now the visitor register in Dublin has to find your home location register in Accra. And it'll send a SS7 message to Accra. It'll ask for a copy of your profile, and the home system in Accra will send it to the visited system in Dublin, and your VLR now has a copy of your subscription information. There's also another database in your home system, the Authentication Center. That's just used to verify your identity. When you access the system, there's no set time when it authenticates you. It might do it every time. It might do it every fifth time that you receive a call or you place a call, you use your phone, you place a short message. The system says, prove to me who you really are, that that's really you. So there are certain authentication vectors that are stored here, and the mobile then gets commanded to perform an authentication. Prove to me this is really who you say you are. And then that goes back to the authentication side. The Equipment Identity Register, it stores a list of what's known as the IMEIs. Remember that from when we talked about identities? IMEI is your International Mobile Equipment ID. That's your hardware identity here. Remember, you have an identity on your phone, that's who you are. Actually, you have several identities. On your subscriber identity module, your SIM card is your IMSI, your International Mobile Subscriber Identity. You have a telephone number that your family and friends use to call you, your MS-ISDN, but you also have an IMEI, International Mobile Equipment ID. That's the hardware identity of this mobile. So this keeps track of the hardware identities of the mobiles. Message centers. This is a store and forward device. If this subscriber, and let's say they're in their home network and they send out a short message to someone, that short message is going to go over the air interface right here. It's going to be sent to the switch, and the switch is then going to send it to the message center. So now that message that subscriber tapped out on their phone is now stored in the message center. The message center then stops everything. It's got to go out and find the recipient. Once it finds the recipient and it gets another message back, it sends that message then to the recipient's network. So this is a store and forward device. So these are the devices that are needed. These are the registers, the databases that are needed to make a mobile. This makes a mobile work. These types of devices, these types of registers. Okay, any questions on that? You okay with that?
So, excuse me. So, basically, what you are saying is the phone that we have, there is a whole lot that goes beyond at the background for it to be functional that way as we use.
Yes. For this thing to work, it takes a lot for this thing to work. Not only for this thing to work, but for you to be able to move around and it work. And for Raphael to call me anywhere in the world. Raphael might take a plane and go to Cairo, I might take a plane and go systems to and a lot of signaling back and forth to Tokyo, yet he can call me and it works. It takes these types of, yeah, very good point. Good point.
Yeah, yes. And
So this is the architecture then. Yeah, please go ahead.
yeah, I saw the PSTN. I think you didn't touch on that one. The PSTN.
Yeah, PSTN, that's, and I draw this little wire line. Yeah, and anytime you see an acronym or something that has not been defined, please let me know, because I know there's a lot of acronyms here.
Yes.
PSTN is a common term for public switched telephone network. What it means is the wireline network. If you divide up the networks, the telephone networks, into wireline and wireless, the wireless are your MNOs, your mobile network operators, or your mobile virtual operators, and any of those. But your wireline, the fixed wireline network, that's called the PSTN, the public switch telephone network. So that's why I draw a little PSTN here. MNO is the mobile network operator. That's just showing that this is an MNO right here. We'll just say all these right here is one network. And there's other networks they connect to. That's for voices, for voice traffic. And they also connect to here. That way, this guy here, he can call his, let's say he calls his friend who is at work or something and works on a wireline network. Well, you can communicate then that way. So PSTN is a wireline network, public switched telephone network.
Okay, so within the system, is there any of the system that could be removed and still be functional? In other case, is there any redundancy in the system?
So what's the question now in the PSTN you're saying, or in the MNO?
In the entire entity, the entire diagram, is there any particular system that we can remove from it that our entire system wouldn't fail? It will still be functional.
I'm not sure I understood the question.
Okay, so let's say something like the HL, the AUC, any of them, the base station, and can we remove one part or ignore it at all? So, and still the communication will still be ensured.
Yes, you could. What would in order to work, this switch is just like a wireline switch over here. And when you talk about a mobile or a telephone switch, it interprets digits. If you have a wired phone, a regular wired phone, you pick it up, you get dial tone, you put in a digit, that switch is interpreting those digits. What do I do with it? How do I route this call? Well, it's the same thing on a mobile network. The only difference is you punch the digits and you hit the green button and everything goes over the air interface, and then the switch receives everything. You don't get dial tone, of course. So as far as the function of a switch, that's identical. This mobile switch could work as a switch without this, without this, without this, without this. Now, if you didn't have this, you couldn't do short message service. If you didn't have a home location register, the system would never know where you're at. The system would there's no way, nothing would work. If I sent a short message to you, but it couldn't find you, it wouldn't work. The home location register not only is a central copy of your profile, it also knows where you're at. It keeps track of where each subscriber is at. You could get by without this, but you could never authenticate. So it would still work as a switch. It's just that you couldn't be mobile. You might be able to go around the world and use this, but no one could find you, no one could call you, and you couldn't have any incoming calls without all of these devices working. Is that what you were kind of meaning?
Yes, that's exactly right.
So this thing, think of this as just a building that has a switch that gives dial tone and interprets digits. This thing here has all of this.
Okay.
Has all of this to make it work as a mobile network. Mobile networks just need more things just to make mobile.
Okay. And also, I've come across certain concepts about a mobile switching center. I've known that some time ago, people used to do that manually. Is that so? If you place a call, if you dial on the telephone, it's a human that's going to connect you to whoever you. Is that the function of the mobile switching center?
Yes, that's the function of any switch. What used to be years ago, if you look 50, 60, 70, 80 years ago, you picked up the phone, you had to ask someone, hey, hook me up to here or send me here. Now that's all done automatically within the switch. That'd be done within the switch here. It's also done within the switch here. The only difference is this switch doesn't give you dial tone. So this switch is responsible to talk to here, to talk to here, to talk to here, just to make mobility work, just to make it so you can move around.
Perfect.
Okay,
Yes.
excellent. So the signaling network, the network that talks, the data, the structure of the data, when this, but it's internal. Its visitor register is internal to the mobile switch. But when this mobile switch wants to talk to its HLR, it doesn't have a direct connection. Like it shows here, it's not a direct connection here, a direct connection here, a direct connection here. If we connected all of these directly to each other, you just have lines everywhere. You'd have connections everywhere. Instead, just like in data, they go through a router. It goes through a routing device. So this routing device is called a signaling transfer point, an STP. The STP routes SS7 messages. So this mobile switch, instead of talking directly to the home location register, will send the message to the signaling transfer point. This will check its routing table and route the call to here, and same with routing back. Again, think of connecting all these devices together without a routing device. I mean, it'd just be a massive amounts of signaling. So an STP is what routes SS7 traffic. STP is signaling transfer point. So SS7 is used then for setting up the call. It's used for short messages. It's used for roaming. So in this network here, when it wants to communicate with this network, it does it through the signaling transfer point. So if I'm going to send if this mobile switch right here, let's say this customer here dials a friend of his right here. He wants to talk to that friend. So the message is going to come here, going to go to the mobile switch. The mobile switch is going to send signaling information here. They're going to talk back and forth like this for the purpose of setting up this voice path. Once that voice path is set up, there's no more signaling until someone hangs up the phone. So the signaling goes over on what's on the red lines here. That's the signaling network. That's the SS7 network. The green line is the voice. The voice is a separate network. It's a voice network. But SS7 is used to communicate to other networks also. So this signaling transfer point will connect to other signaling transfer points. Just like in the data world, a router talks to a router. It's just it acts the same way here, except they're called signaling transfer points. So networks then tie into each other. So a mobile network over here will communicate with other mobile networks throughout the world for roaming purposes. So if you have a network, let's say Vodafone, and here, and you roam over here to Verizon, well, Verizon has to talk to you, because if I power my mobile phone on, let's say this is Accra, this is Ghana. And there's a telephone company here. I fly over from Chicago and I fly over to Ghana and I turn my mobile phone on. Once I do that, the mobile switch has to communicate with my home system. It has to ask my home system, give me a copy of Steve's profile. I need a copy of Steve's profile so he can use his phone in Accra. So it's going to send SS7 messages from the switch through the VLR. The VLR is going to communicate with a local STP, a signaling transfer point in Ghana, and it's going to go through these international carriers. It might be one, it might be multiple. These are signaling aggregators. We talked about signaling aggregators when we looked at the mobile industry, but these are companies like BICS, BICS, Cineverse, TNS, iBasis. These are large international companies that provide signaling services, and they connect all the networks together. Because this company here in Accra doesn't need to communicate directly with Verizon. If every mobile network had to communicate with every other mobile network, once again, you'd have just all kinds of connections. If you signed 200 roaming agreements, you'd have to have 200 connections to all these other networks. That's not practical. So you go through these aggregators, these signaling aggregators. So in Accra going to Verizon in Chicago would go through a series of these STPs, these routing devices, end up here. It would get the information and it would send it back. That's how they communicate. SS7 is used in second generation and third generation mobile networks. Second and third generation mobile networks use SS7 to talk to each other, and they go through these signaling aggregators.
Okay. So if let's say for the purpose of roaming, let's say I am in Accra and then I move to California, and is it better to just buy a new SIM over there and then start using their system, or should I
That's a
go
good
to
question.
the roaming aspect?
If you have a telephone number and if you stay within the same, let's say, country, you might as well keep the same telephone number, right? I mean, you're a permanent roamer.
Yeah.
Now if let's say you move to Dublin, Ireland, well, now anyone that calls you is going to call your local Ghana number, and then but the network would treat you like you were roaming all the time.
Okay.
As long as there's roaming agreements, the signaling would work. Now it might be expensive. Might be expensive for you to incur roaming charges every day, but it would work.
Okay. But I was asking, is it better for me to switch to a new SIM in that location, or I should continue using my own?
That's another good question. In other words, just temporarily, you mean, right?
Yes.
Like if you visit, you could get a new SIM card. There's advantages to getting a new SIM card. I usually keep my same SIM card. Like when I travel, I'll keep my same mobile phone, and it costs like $10 a day, I think, or something if I'm roaming internationally. And that allows me to use my mobile phone just like I'm at home. So to me, that's the most convenient, but you can save some money in the long run if you get a new SIM card and a new phone number.
Okay.
Yeah.
Yes.
Good.
That's good. Yeah.
Okay.
Yeah.
We're going to talk about data next. We're going to talk about on Friday. It's 12:03 now. On Friday, we're going to pick this up at GPRS, General Packet Radio Service. This adds packet data to the network. So not only is the network used for voice, but the network can be used for packet data. Now, in this time frame, though, the packet data is pretty slow. You can't, and back in the 90s, you could not download hardly a picture, certainly not a video. if you tried to download a video back in the 90s, you might as well start and go to bed and wake up in the morning. You'd probably still be downloading in the morning. So it was very slow data. But again, this is the start of data. You could download some documents. By the 2000s, you could do some pictures. By the 2010s, then you could start doing videos. But this is slow data. This is the start of data. So let's pick this up on Friday. And we'll see you at 17:30 hours. I think it's 17:30 hours.
I think we have a question.
Oh, question, yes. Oh, here you go.
Steve.
Hello.
Yes, please.
Yes, I wanted to know, before the introduction of mobile databases for the mobile networks, how were the PSTN networks like doing the signaling messages? How were they routing the signaling messages?
They would route their signal. The question is, before mobile networks, how were they routing?
Before
Mostly
the databases were introduced, for the, I remember something like using the like a protocol in SS7 to do the signaling routing, signaling messages, to route the signaling messages. Before that was possible, how were the PSTN networks like doing the routing the signaling messages? Like how are they able to send the messages to the networks?
like you're talking about, like for you pick up the phone and call your friend somewhere. How does that message route?
Yes.
So I think
before the introduction of the databases.
If I'm understanding you, before the introduction of the AUC and the HLRs and EI, all those databases, like before those things, how were the PSTN able to
networks able to do
Okay. First of all, remember, HLR, EIR, VLR, those are only in the mobile network. In a landline network, you don't have to do that. A landline network doesn't need to keep track of you because it knows where you're at. You can't take your phone and cut it and then go somewhere else and have it work. On a wireline phone, you're tethered. So it knows where you're at. It doesn't have to keep track of anything. So you don't
I remember. That's true. I remember now. I remember you mentioned that in an earlier class, so it makes sense now. Like the telephones are in your house, so there's no need to look at where you are.
No need to keep track of you because it knows where you're at, right? You can't move.
Yes.
But to answer your question, we'll take a look at how calls later on. We'll take a look at how calls actually get set up, because there is signaling that happens in the wireline network. It's just that the wireline doesn't need these databases. It does need some databases. It needs like number portability databases, but as far as keeping track of you, it knows everything about you. You can't move. It's got you tethered down, right?
Yes. Thank you very much.
No, that's I'm glad. That was an excellent question. Excellent question. Yeah, these are mobiles only. So anything else?
Yes. Okay. So I wanted to take the class a bit back. We've already treated the concepts, but with the CDMA, I found it a bit. It's not adding up to me clearly for the CDMA. So can you briefly touch on that one for me?
On what CDMA is?
Yes, the CDMA.
Yeah, CDMA is just a technique for how you modulate your signal over the air. In other words, it's a digital technique that assigns a unique code to the mobile here and a unique code to the base station. So these two are using the same frequency as everyone else, but they're only listening to their one code. They hear everything, but they only listen to that code. It's almost like noise modulation. And again, remember the analogy we use. If we're in this room, we're in this large room, and I see you about 10 people over. I can see you, and you and I are talking English, and everyone else around us is talking French and Arabic and everything else. But I kind of filter all that out, and I see you over there, and you and I are talking like this. That's CDMA.
Okay.
CDMA is I filter everything else out. I don't want to hear them. I want to just talk my language to you. Think of CDMA like that.
Okay. Good.
Okay?
Yes. Yes. It's adding up.
That's the analogy in CDMA. Whereas here, we're using the exact same frequency, but instead of filtering out noise, I have a time slot. I can only talk for 4 milliseconds, then nothing. Now you don't know this as you're talking, but the system is dividing you up into time slots. That's TDMA.
Yes. Okay. Good. I think it makes sense. Like going through the
Good.
notes, it's adding up to me. Also, I know the time is over, but I just have one more.
Okay.
For frequency modulation, I've been trying to wrap my head around frequency modulation. Like
This
what makes
first one right here, you mean?
no frequency, like the term frequency modulation.
Oh, like
Yes.
FM. What is frequency modulation?
Yes. Yes.
Yeah. Frequency modulation is you vary the frequency. In other words, you in some frequency just think you're going like this, and some is you vary the frequency as you communicate, as you talk. Whereas amplitude is almost like you talk louder and then talk softer. That's amplitude modulation. I got some slides, I think. Let me see if I can find those slides that define the difference between, because there's really 3 types of modulation. There's frequency modulation, there's amplitude modulation, and there's pulse modulation, which is like radar. But
Okay.
let me see if I can get an analogy for you the next time on Friday, what frequency, AM and FM, what those 2 mean.
Okay. Okay.
Okay?
Yeah. Thanks very much. That was awesome.
Absolutely.
That was
Absolutely.
awesome. Okay, guys. So I believe everything was well understood. Okay, if you have any question, you know Steve's address. We are in the same group as well, so you do a follow up on that. In the meantime, we will have a nice break over here.
Very good.
Bye.
And we'll see you,
Next Friday.
unless something happens, we'll see you on Friday at the same time.
Yeah, bye.
Okay. Thank you very much, everyone. I enjoyed it. Thank you. You did well. Talk to you later.
You too.